Hello, everyone. Welcome. Okay, so here we are at the first ever node with me. Excuse the uh, code with in the top right corner. Uh, Nodes are a little new to me. I've played around with nodes in the past, but not my forte. So we're going to be looking at some action graph samples that were released, I think, with the last version, this current version of Create, and we'll be diving into just node by node what's going on, what it's doing. For I'll briefly cover what just some of the features of Action Graph, how to work with it, and but if you're looking for like a brand new tutorial for Action Graph, I'd recommend either the Action Graph Quick Start here in the documentation. I'll put a link to that. This introduction to Action Graph video is also very good, and this Action Graph with USD curves, which is has changed a little bit, but I think you can still follow it. So those are great resources to start. And yeah, if you're here, let me know. Say hi in the chat. This is going to be very interactive. Hopefully, you can stop me at any time, ask a question about what I'm showing, ask for clarification. I'm not going to be creating anything for this one like I normally would with the code with me. This is going to be just an overview of these samples, and we'll learn this together. So welcome Ashley, Funky Boy, Shang-Chi, Chi-Shang. Cool. All right, thanks for coming. So let's do it. All right, so here I am in Create. First thing that I wanted to show you is where to find these samples. If you go down here to these tabs, there is a samples tab, and there are samples for lots of different things. But there is a visual scripting tab here, and these are the 4 samples that we're going to be looking at. If the first time you open them, if it takes a little bit of time to load, it's downloading some thumbnails, I think. So give it a little bit of time the first time, and then after that, it should be pretty straightforward. So to start, probably the easiest one to go through would be the light bulb. So go ahead and look at that. These samples have some text to kind of tell you what to do. If I press space or press the play button here, it will enable it'll enable the action graph. And you can see here that now I added these 2 buttons. And there's also this other prompt here that is click on the bulb to change the colors, click on the switch to turn it on and off. So I can click just on the bulb itself and it'll change colors. And I can also click on the switch to turn it on and off. And then just as a helper, there's also these buttons here to do the same. Oh, a little bit of delay there on the redraw. So that's the basic pattern that we'll see in all of these samples. Is it'll give you a prompt on what to do to try it out. All of these are activated by playing the simulation. Once I stop it, you see the buttons go away. The state is still preserved from where I left it off. But now clicking on this brings me back to the editor mode. So I can't. So I could definitely break this. And so that's the basic idea there. And another thing about these samples that you kind of want to look out for is the camera is actually locked. So if I wanted to zoom in and out, you'd think, oh man, this is broken. Why can't I move my camera? They're intentionally locked. And so what I typically do is create a new camera from view. I really don't want to be that close to it. Oops, but now I'm inside the other camera. And now I can get a better view from anywhere. And the sample works from any view location. I think the developers just wanted to make it remove complexity, remove things that you'd have to deal with. So on to the nodes. Can we use Action Graph on Omniverse XR? I think so. I don't see why not. You will probably, what probably won't be supported is these UI elements. These are actually created by the node graph, which we'll get into. But I will confirm. That's not something that I know for sure, but I don't see why it wouldn't work with Omniverse XR. So let's take a look at the node graph. You can go to Window, Visual Scripting, and open up the Action Graph. This is the editor for the graph. And then you could create a new Action Graph from here. You could also edit one. And so when I click Edit, it'll give me an option to open the only one that I have in this stage. And here is the graph. And if I had more action graphs, I could swap to different ones from here, which you'll see me use that feature in a little bit. You can also create a new action graph from the Create menu, Visual Scripting Action Graph. So this is my main layout for laying out nodes in my graph. This is my palette of nodes. I can expand, they're grouped into logical functional groups. And I can grab any one of these, bring it in, and then start wiring it up. I can also search for something like constant double and bring that in. You can also, I believe it's tab. Yeah, you can tab within the graph and search for something this way. So, and then bring it in same way. So whichever way you prefer to work. Variables has the variables defined on the graph. So these are input and output variables that are defined on the graph itself. And we can see also here in the stage, everything that we've created here is also reflected on the stage. So here's the graph, and here's every node that was created within this graph. And you can see as I click on the stage, it highlights the nodes on there as well. And if I look at the graph itself, you can see that here are the variables that are defined. A bold color, which is a 3, float, I think. These are probably floats. Yep, color 3 float. Boolean for whether the light's on or off, and the switch speed, which is set to 0 right now. That's yeah. So that's the graph and the stage. And nodes typically have input connections, output connections, and they also have these execution connections, some of them. And these are colored by their type. So pink here is a token. This darker pink is a string. So you can hover over these and figure out what type it wants inputted here. And you do want to, you can't connect something that's not a related type. So if I try to connect this pink one to this red one, it doesn't work. This blue one is a bundle, which we'll get into later. For the output, I was trying to find, there's also a white connection, which would allow for any. Typically, even though it says any, it probably expects a certain type, but it'll be flexible in that maybe it could be a double, or maybe it could be a float, and it'll be flexible in that way. So data flows in and out through these. Execution is controlled by these. So you'll see that this one will only ever execute whenever this one fires. So whenever this thing sends a signal through the execute out, this node will actually perform its operation. So some of them will only trigger on that case. Others, like this one, will trigger on demand. So this one will only trigger because it's an input of this one. So when this one is triggered by this execution connection, then it will say, hey, what's my input? And it'll go back and check to see what the value is that it needs from there. These are the variables. So this is what the variables look like in here. And the ones that we just looked at. And these are the nodes that are writing out variables. So we'll look at those more closely, but that just about covers all of the nodes. There are these, yeah, and lastly are these backdrops to organize your nodes. You can, if you take it out, if you have it on one of these, it travels around with it. If you take it out, it becomes independent. So very, very handy to organize your nodes with this. It really helped me learn these node graphs better just by having them grouped like this. So let's get into the nitty-gritty of what this node graph is doing. I think we can start with the UI. So one of the cool features of Action Graph in these recent releases is this UI group of nodes. So you can actually build UI on the viewport like we saw using nodes. And this is actually how the car configurator from GTC was actually built in this way. So Action Graph right now really excels at creating these experiences, whether it's what we're calling smart objects, objects with behavior, or just experiences where you have some animation or behaviors that are occurring, and users can interact with the scene in that way, more so than say procedural modeling like you would in Blender. That's not necessarily one of Action Graph's strengths right now. So we'll look at this example and you can see just how it does this. These green ones are event nodes, and there are two events that start this out. You can see here that both of them, this one will only fire on when the OmniGraph is when you press play on it, you start the simulation, and this one will fire when you stop the simulation. And if you see anything that says OmniGraph, OmniGraph is the lower level technology. It's the framework that Action Graph is built off of. You can build any sort of graphs that you want in Omniverse. So Action Graph is our flagship graph network that we have, and we have lots of nodes for it. We also have the animation graph, and both of them are built on top of OmniGraph. So first thing is when this thing fires, basically when I press play, it's going to then execute this one. And what is that one doing? That one is putting the viewport into scripted mode. And what that means is that now I can't interact with the viewport like I normally would, which seems like a hindrance. But no, if you're trying to create these experiences, like think of like a iPhone App Store, you want some very controlled environment. You don't want a 3D editor for that. You don't want your users always interacting with a 3D editor. You want to give them just a very refined and direct experience. So you take complete control of the viewport with this node, and from then on, your graph decides what the user can and can't do. So we'll see now that the only thing that we're allowing a user to do in the viewport is click on this and click on this, which is creates for a really streamlined experience. So it puts it into scripted mode. It enables picking, and it's affecting viewport named viewport, which if I click on there, I can see the name of this viewport. If I created a new viewport, it won't affect that one. And then it's putting a widget on top of this viewport that you can't see, it's invisible. But this is where the rest of the UI elements are going to go, and it's actually receiving all the clicks on behalf of the viewport. When I stop playing, it's setting it back to default mode. This is the mode where I can actually click on stuff and interact with it like a normal editor. And it sets it back to enable picking off. And again, this is affecting that primary viewport. Cool. So this one, it only gets put into scripted mode. When it gets put into scripted mode, it's going to fire this one. Do you know if there's a way to package up your graph as a script? You can definitely save your graph as a USD file, and you can then reference that into other USDs and apply them to other. Say if I had another light that was structured in a similar way, I could drop it onto that light and have it affect that one. You could also put it into an extension, but at that point you're writing code to then, once you have that USD file saved out, you could then reference it into any scene and do that stuff on behalf of the user. So if you wanted to have more of a scripted experience, you could do that. And lastly, we do have the OmniGraph controller API, which is a Python API to just basically create graphs and nodes all scripted, but you would have to then manually, logically dissect what you did with the graph and then convert it into code. I don't think we have a way to automatically produce code from a graph. Good question. So this placer node, this is basically just a positioning element. It's almost like a transform node in 3D. You just tell something where to go, and then any child is positioned relative to that. So that's what this placer node is doing, and it's saying position on the screen 20 pixels in X and 40 pixels in Y. And we're going to call this widget, this placer, light placer. This is important because then in other nodes you can refer to that widget by name. And this is the widget path. This gets generated automatically. So let's see what that looks like. So this is actually the parent for these buttons. We can see later on here that these are the buttons that are getting created. So if I tweak this and reset it, I think that moved. Let's do something a little bit more obvious here. There you go. So I moved over more in X. So that's what that placer is doing. This stack, basically anytime you want to have UI elements grouped together, you need a stack. In this case, it's going to create a layout in top to bottom form, and you can switch this to a Z stack, which would be stacking your UI elements like a deck of cards, or left to right, a horizontal stack. And so this works just as a way to lay out multiple elements without needing to specify for each one where do they go. We only specified a position for this, for the group, for the stack, and then these are going to get placed automatically within that stack. So you give it a parent widget, and again a name for the widget for this stack in case you want to refer to it in the future. and the direction of course. So if I switched this to left to right, stop and play, now you can see my buttons are laid out left to right. Let's go back to, what was it, top to bottom? There we go. All right, and then these buttons. So you can see that all of these are getting called back to back. As soon as I press and the reason that I have to stop and play every time is that these are only firing at the moment that play is started. So even though I made a change here, and this is just good debugging hints, right? Even though I'm doing this live here, that's probably too much. It's not going to take effect until I stop. Then I press play. Then this event finally fires, and all of these will get triggered again. So that's an important debugging process. Is think about when your node is supposed to fire, and if it's not updating like you expect, it's probably not being triggered. So what is it that's triggering it? Is do you have the logic that you want for the triggering the way that you'd expect, or do you need to adjust that? So all of these, you can see they're kind of meant to be connected back to back. First you make a placer, then you connect that to the stack. Then once I have the stack, let's put the buttons, and then those are all just sequentially connected. Cool. Then again, for these buttons, we define what the parent is. They're parented to the stack. We can define a size for each of those buttons and a style. So this is all defined in, we have documentation. So what's really cool is that we're exposing this developer content to Python code in Node Graph. So you actually have full control over how to style your buttons, and you can put images. And again, if you haven't seen the 3D car configurator, totally check that out to see like just how far you can push this. And same story with this button. Yeah, that's about it there. Let's take a look at the next group. Any questions about that group? I do need to move a little bit faster because I want to try to cover all the samples. But I know I did a fairly long intro. All right, let's move on then. This one's really easy. I'm only going to cover this once. It's in the other ones as well. This is the on-tick event. This one fires every update loop. So every frame, every as fast as your computer can update. So this will fire on every tick, and on every tick we are updating we're drawing this text on here. So this one I can, if you watch this press play text here, I can update this live, and you can see that because it's updating every frame, any changes that I make here will be live. Whoa, that got wild. Let me, well, I destroyed this. No. Don't crash. Yeah, sorry. I wanted to give you guys this preview on the new this new version because the samples have changed a little bit, but we are still working out some kinks here. All right. Here we go. Nice and clean. And Visual scripting. And we're back. So yeah, so that's just it's using a draw screen mostly for debugging, but it also works really great for these prompts here. You can change the text, position, size, background color. Pretty straightforward there. Light and light switch. Let's take a look at this one. This light switch, there are two UI nodes here. This one is on picked, and this one is on widget clicked. So on widget clicked is if I click on this widget, and it could be any widget, but in this case we have a button, and we've identified that widget by name. So if I come over here, this is called light switch. So this one, we've identified, oops, I'm looking at the wrong one. This one we've identified it as light switch, and we're saying when this widget is clicked, then, sorry, we identified it there. When this widget is clicked, it's going to fire this clicked, it's going to execute the next node in the line here. So that is going to write a variable called light on, which we saw. So we can, right now it's off. Sorry, need to press play. And I did the wrong step. Light toggle, we're talking about this button. So I've clicked it on. And if we look at, do we need to see it here? That's the default value. There it is. It's checked on. So that variable is now checked on. Start it up again, toggle it off. You can see that the value is now off. So that variable is going to be referred in the future, but this variables also help keep your graphs very tidy. You write to a variable, and then some other section over here, it will read from that variable, and it keeps your noodles from going all over the place. And then this is a very cool trick here. So this is reading in the value, and every time that we click, it's going to fire this. It's going to check back to see what the value, what value it should write in there, right? So this is saying write whatever value is being inputted to the variable. But when it goes back to find out what that value should be, it actually goes back to itself. And so it's going to take whatever value it's at. So if it's on, it's going to flip it to off. It's going to do a not operator, and it's going to switch it from off to on, and then it'll write the opposite value. So very cool trick there. And this other node is the onPicked. This is the one that if you click on the viewport and you are clicking on any of the prims that are tracked here, which in this case is the switch mesh, then it will fire this picked execution. So I click on here and it will fire this bit. So this variable is being written out whether I click on, this node is being executed whether I click on one or the other, and I can switch between the two, and it does the right thing. Doesn't matter which order I do it in. So very cool pattern here for executing the same node from two different, in two different ways. All right. And color, yeah, we can look at color next. So we looked at the click events that are firing the light switching on and off. The other one is the color switching. So this is the same pattern. We have the unpicked. If you click on the bulb, we can see here that we're tracking the bulb prim there, and you can have as many prims as you want that you're listening to, or listening to see if they've been clicked. Or you could click on the widget called color switch, and that will switch the color. And so again, we have the same pattern, two different triggers that that can execute this multi-gate. And then this is just this multi-gate is just cycling through each of these. So the first time that this node is triggered, it will fire this one. Second time it'll fire this one. Third time this one, and that one. So that's how the cycling is happening here. Every time I click, it's going to write out a different color. So let's start with the red. So the first time I clicked, I was on white. I clicked the first time, it's going to fire this one, which means that only this one is this write is going to execute. And when it executes, it's going to check to see what, it's going to ask for this value, and it's going to check this node and say, oh, this is red. Okay, write it out. Second time I click, comes over to this one, and it will grab it from here, and then blue, and then white. Okay, so again, these are just being written out as variables. We're not doing any changes to the scene yet for both of these groups. Let's see where that changes. And that's this last section. First thing we're going to check is to see if what the value of the light on is. And we're going to convert that the first time into a double. We'll start over here. We're going to convert to a double. I think that's where I want to start. Yeah, let's start here. It takes the Boolean, which is 0 or 1, and or true or false, and converts it into a double, which would be 1.0 or a 0.0. You can see here that because I'm on simulation is being played, these values are updating on the fly, and I can use that to debug. And once I get that value, I'm multiplying it by this constant, just 50. And this is what's going to be used for the rotation of that switch, 50 degrees. So then here, it's fed into this vector 3, and so it's going to rotate on y in 50 and 0 in x and z. And then it's going to use this node to execute the rotation. And this node, you can see here that it is listening to be updated on tick. So every frame, it's checking to see if anything's changed, and if it has, then it'll fire this rotate to orientation animation. We have the switch speed, which is set to 20 here. This is the speed of the rotation, or how quickly it should do that rotation, and then the target of what it should rotate to. So in this case, it's already rotated to 50 degrees. When I click on it, it'll say no, now rotate to 0. It'll take the time based off of that speed value to do the rotation. So if I were to change the speed value, it's going to be coming from the variable. Stop, play. I should be able to slow it down. There, nope. Action graph, switch speed. This is something that I'm not entirely sure about. I noticed this last night as well. All right, I'll have to take a closer look at that. So that's going to do the rotation, and then even though I've already it's doing this rotation, it's not actually going to write the rotation. It's not actually going to do anything until it's written that No, that's it. So yeah, this will take care of the rotation. Then let's take a look at the color part. So again, light on. It needs this variable to know the intensity of the color that it's applying. And so here, again, as I toggle the light on and off, that variable changes from 0 to 1. And we're multiplying this time by 10,000, since that's going to control the light intensity. And then we plug that into the shader's emissive intensity, and also the light. It has a light and an emissive shader as the intensity of that light. And then both of these are executed only when this one's executed, which is only executed when this one's executed, which is every frame. And the color for these shaders, it gets updated every frame as well, and that is based off of that color variable that's set on the graph, which we set up here. So that is the light bulb. Any questions about this one before we move on to the next sample? Okay. Next one will be the desk fan. All right, let's take a look at this graph here. We're going to edit. And here we go. So let's, again, let's play this and see what it does. So it says space to play. And you can left mouse drag to rotate the fan. You can rotate left and right, up and down, and you can get into this, all sorts of different orientations that way. It does look like it's locked, so I can't do a full 360-degree turn. And I can control the fan speed with my mouse scroll. And I can middle click to reset. So if I get this into a weird configuration, middle click and it'll reset the orientation, but not the speed. There's a question, can you make the button work by adding an action? Can users only using the view interact with such actions? What do you mean by actions? So what we did show is that the button will trigger, you can have a node that will listen for the button to be clicked, and then you could, if you mean by action a behavior, yeah, that behavior can be triggered by just that button click. So here the reset fan is an example. We have a button for that. I can click on here, and this part of this node graph, it's just a graph in itself, a subgraph in a sense, will only be triggered on that click. Yeah, there's other triggers too, but well, these two. But I could just, if I wanted to, I could just have only the button do that. Let me know if that answers your question, or if you meant something different. All right, so just very quickly, the info text, this is the exact same thing as last time, so I won't be covering that, but you can see that's what that is there. And let's look at the UI creation again. I'll only cover it very, very briefly because it's the exact same pattern. We have the start and stop events that trigger a scripted or back to default modes. And then we put a placer and a stack and just one button. Then let's, what the prompt doesn't tell you is that there's also keyboard controls for this. So let's look at that reset button now. This one is going to, you could trigger the reset by either clicking on numpad enter or clicking on middle mouse clicking on the viewport. So you can say on a viewport clicked, you can specify left, right, or middle mouse, or by clicking on the button. So it's a little bit of a mess here, but all three of these are connected to each of these write operations. And this is going to just reset the value of the fan up and down variable to 0, reset the left and right to 0, and reset the fan speed to 0. And when it resets the fan speed, it's also going to do this rotate to orientation that we saw to do the play the animation to get there. So press numpad enter, and it'll get there. I actually don't know if it's I may be wrong. I thought this was supposed to play back like an animation, but I could be wrong. I'll need to double check on that, because it is, from what I can tell, it's snapping. Yeah, I'm pretty sure yeah, I'll need to check on that. So we write these three variables out as a reminder. These are the variables on the action graph. You can also see them here. And I believe you can get a read node from there and a write node from there. And also you can define new variables. So those are your variables: fan body or fan blades. I think we'll do let's do the fan body first. It is more, but I think we'll start there. So another UI event here is the read viewport drag state. And what is being read here is the velocity. So this is returning an X and Y speed of how fast the mouse is moving in X and Y. So that's actually being used to not to define the, it's not going by my mouse position to figure out the orientation of the fan. It's actually just going by how much I'm changing in a given direction. So by that velocity. And so you take that double 2 and you break it up into two separate values, X and Y. And the keyboard, it can also be controlled by keyboard numpad 6 and numpad 4. So 4 for left, 6 for right. And this is pressed is a Boolean. And again, we're just converting that into a 0 or 1. And then we are subtracting them. So if you're pressing both buttons at the same time, they'll cancel each other out. Is basically what that's doing. But if because this is subtraction, left would give you a negative number and right would give you a positive number, and when these are being pressed. So then you add not sure why we're adding here, but you're adding the let's watch this. So you can see here, as I move this, faster strokes will give me bigger numbers. Smaller ones will give me a smaller number. And I'm guessing this one just gives you, we're adding them to give you kind of a minimum amount of movement. So when I move, second is always 0 there. Oh, because I'm not using, this is adding the result from the drag and also the keyboard state. So potentially, you could be dragging and doing the keyboard state at the same time. So that's what that's handling. And so from that, we get the total amount that basic movement amount. And you can see here that I'm doing this is with that keypads. It's a fixed rate. So we're taking those values. We have the current left and right values. So this is an angle. You can see here if I go all the way to the right in this case, it goes to negative 100 degrees. If I go all the way to the left, from the fan's perspective, it goes all the way to 100 degrees. So this is just taking whatever value that we get from the drag, and I didn't mention here that we're only grabbing the x value from that drag, right? We left and right is only controlled by left and right movements, not up and down. We increment the angle based off of that velocity, and then we clamp it to between negative 100 and 100 so that we lock the rotation like I showed. And once you have that value, you write it out. And you can see here that this isn't getting written out when the drag is happening. It's actually getting written out on tick. Then same story for up and down. This is 8 and 2 for the up and down. We're reading the up and down variable. What is the current rotation in up and down? And then we're incrementing it based off of either the button presses or the drag. And we are locking it again between negative 100 and 100. And then we write it out on tick as the angle for that fan. When again on tick, when these variables are written out, we also write them out to the rotation properties on the body group and the arm group. So this is two different nodes that are being rotated. If you pay attention here, we have this pivot here that controls the left and right, and we have this pivot here that's controlling the up and down. And what happens here? We get this angle, we multiply it by some constant 0.6, and then we make a vector here to rotate on the y for left and right. And then we write it out on tick. Again, this is coming from the on tick. We write out that XYZ rotation, which in this case is just manipulating the Y. I misspoke. The angle is actually between negative 60 and 60. So even though the variables are basically ranging from negative 100 to 100, this constant is then shrinking that down to angles between negative 60 and 60. So that's what those two are doing. And same thing for up and down. It is a 45-degree angle in this case. So you take 100, multiply it by that 0.45, and so at the top, when it's looking up, it's negative 45, and it's writing that out. So that's rotation. Any questions? Okay. Fan blades. This one is really fun, only because, well, not only because, but I'll show you in a moment why I think it's fun, and you'll only notice it if you go around and hack in here. So we have scroll state. So this is a new node. You can read whether the mouse wheel is being scrolled, and it gives you a scroll value here that we are taking. It's either 1 or negative 1. Okay, so that's on and off. And again, we're accommodating for whether the keyboard presses are happening. In this case, these are using the plus and minus buttons, and they're both being taken into account to decide how to affect the fan itself. Fan speed, same pattern as the rotation. We're going to take whatever the current fan speed is on these events when this event happens, and we're going to increment the value based off of that. So I'm going to use the plus and minus buttons here. As I press plus, you can see here that it's incrementing between 1 and 2, and you can see the result. The final result is there, and it is getting clamped. Sorry. Let me disconnect this because it's easier to see. You can right click on a noodle and disconnect. And I'm gonna put a const double. Okay. So now with just the keypads, you can see here that as I press minus, that value drops. As I press plus, that value increases until I reach a particular limit here, which is 100. And that 100 is being clamped here. So even though this increment doesn't have a clamp, what's happening is on the next loop, this thing gets clamped to 100. It gets written out, and so when we come back over here, it's already clamped at 100 for this input. So we're clamping between 0 and 100, and then on tick, we are writing out that value for the fan speed. And that value on tick again is being written out to the prim for the XYZ rotation, or just it's rotating on Z. So the other ones are going to be 0 here. I don't remember what that part does yet, but so we take this input value 100, multiply it by this constant about how much we want to rotate every frame, and we get this 270. And with that 270, we write it out. Oh, this is the dial group. Okay, we'll come back to that. So for the actual fan blade, it's a negative rotate, constant negative 12 for the rotation, which is multiplied by the 100. So we get negative, at the max speed, we get negative 1200. Then we multiply it by on tick. So this is going to, based off of how long it takes for every update loop, we're shrinking that down so that it's not tied to the update loop, but it's actually animating in seconds. And this is delta seconds. So between this loop and the previous loop, how many seconds have elapsed? And it's some tiny number here. So we multiply that big rotation by how much we want in that sliver of time. And here we can see every update loop, how much it's rotating. And then here, it's taking the current rotation of that fan blade and adding that offset amount for that frame, for that update loop. And that's how we get the update every frame on the fan group. If I want to reset this number, because it's going to get huge, that's where the reset is going to help and reset that. So let's get that spinning again. The dial, there's a dial too. So unless you unlocked the camera and came back here, create a new camera, there is a dial here too. And if you look very closely, it has off, low, and high. And here's a little marker. So as I press play, press minus, it goes all the way to off, press plus, low, and high. So that rotation, just like the fan blade, is being controlled here. It's just that it's not doing, it's not adding to the rotation. It's just setting a rotation based off of the fan speed value. So every frame it's going to keep that value unless I change it. So very, very nice detail. That's the fan. Any questions? Well, we're doing pretty good time. I usually do these for 2 hours, so I'm going to try to run through all of them in this session. Any questions about the fan before we move on to the clock? All right, or it doesn't have to be about the fan, just any action graph questions that might come up as we look at these things. All right, the clock. Don't save. Okay, so this is a countdown timer. I can start the clock. Again, we have buttons and also interactive clicking here in the viewport. So I can click on this start button and it starts to count down. And here I also have this debug text to let me know how much time is left, and also the speed, the countdown speed. You can manipulate time. And at the end, once it reaches 0, it'll say time's up. So we can click the start button, we can reset. I'm going to stop and reset. And I just love these samples because they're so intuitive, right? It's you can actually click on these objects and have them interactable. Scroll to set the seconds. So I can increase how many seconds I want to count down from. And then I can control click for how many minutes, and I can alt click for how many hours. So then I can start, and this is going to take a really long time, which we're not going to wait for. But there's also this horizontal drag to change the clock speed. So for this one, you'd want to click on here, and maybe you could make it work to click on there, but really the drag, it's just listening for any drag. So this will multiply the countdown speed. Here's our 22x countdown speed. Cool. So that's what this one does. And then we have the buttons to do all the same stuff. Reset the speed, stop the clock, and reset. I'm going to set this speed to something kind of, I have this habit that I want to drag that thing, and it feels like I'm dragging it. That should be fast enough. My pen. There. Cool, so lots going on here. As I changed the countdown start, you saw that these wheels were spinning, and these are translating up and down. This is translating left and right. And if we look at the innards of this clock, it is mechanical, just as you would expect. There's no shader trickery here. We have dials with numbers on them, and double-digit dials. So the double digits are larger here since they go up to 60, whereas these, or they go from 0 to 6, whereas these go from 0 to 9. And all of this is programmed in the node graph to work. So let's take a look at how it works. I was trying to rotate the camera again, and it was not letting me. There we go. So this is gonna be cool. All right, let's hide that for now. I mean, let's not show the insides. And we're going to edit this graph here. And once that kicks in here, whoa, lots of nodes. But there's a lot going on here, right? We're counting in seconds and moving 6 dials and all of that. Good place to start. We have our info text again. We have another UI. This one's pretty straightforward. It's 3 buttons in a stack like we've seen before. The reset, if you click on the reset, it's going to, what is one going to do? This one's going to press down on the reset, and then it's going to bring it back up after that. So this one is animated. And then it's also going to write out the current seconds too, as it's going to reset it back to 0. This current seconds is counting. Where is it? Can I get it from here? No. Maybe. No, we'll go back over to where this is written. Here we go. This is actually current seconds is counting up, which is different from what you'd expect, right? Or it's a countdown clock, you'd expect it to count down, but current seconds is counting up. So I think that's a good place to start, is acknowledge that. And we've looked at that tier there. Set time. This is the logic for setting the start time for the countdown. So if you scroll or if you press the keyboard, no, it looks like it's just scroll. I don't remember if there's a keyboard. I don't know what this A is doing. But as you scroll up or down, it's going to increment or decrement the hours, minutes, and seconds. And oh, and this is the I don't know why it's checking for A here, but with the scroll, if nothing's being pressed, then it would do seconds, and if you control scroll, it's minutes, and alt scroll, it's hours. So here we go. So the letter doesn't matter. It's taking the output for alt, whether alt or control is being pressed. So if alt is being pressed, this one will fire true. Otherwise, if alt is false, then it's going to fire this check. And if control is false, then it's going to do seconds. If control is true, it's going to do minutes. And if alt is true, it's going to write out hours for the variables. Those variables will then be used in this set time. I think that's where we want to go. Set time is going to rotate these wheels to set the time. So that's what that's doing. Hour set, minute set, and second set. This is all similar to the other ones. You have some predefined rotation for how much that value should should affect, and then you multiply that unit of rotation by by the value that's coming in. Then this one is going to write out the start seconds. So based off of on tick, it's going to check it's going to add seconds plus minutes and hours. It's going to convert those into seconds as well, add them all together, clamp at some upper value, since this is actually physical and there's a maximum amount of time that we can actually do. And then it's going to write out the start seconds, which is going to then inform these dials about what their start state should be. And that is here, spin time wheels. Do I want to go there? I won't go there yet, because I think it's more important to look at these first. All of these are feeding that spin the time wheels. This is drag state for the clock speed. And all this is doing is it's writing out this clock speed variable, which is then used, if we're translating this based off of that variable to represent that visually. And this is going to multiply how fast the spin wheels is happening. So there's that one. Thanks for coming, Funky Boy. Start clock, whether you click on the start button or you click on the widget, we have this pattern again of flipping the graph variable, reading it in order to flip it and write out the flipped value. And we're going to just translate this button down. So that one's easy. Display timer. This is the debug text up here that is counting down. And the one new thing here is that we have a select if, and if the, what is this? What is the condition? We're comparing A and B. So as this is counting down, if it finally reaches 0, if it's equal, then if that's true, then instead of showing the seconds, show the times up. And then it's grabbing these variables, current second, start second, in order to subtract them, right? Because this is counting up. And then the clock speed is written in that times X however many multiplier. Countdown. This is, again, just this is taking into account the clock speed and multiplying the delta time by that clock speed. So for every frame, it's going to figure out how much time has transpired since the last frame, and it's going to multiply that real time by the clock speed to then increment the current seconds by that amount. So here we can see that it's incrementing by 0.2 every frame. Whereas if I increase it, you can see that's going up. Decrease it all the way down to 0, it stops. Then we clamp how much it can actually increase or decrease by, and in a given frame. And here we are branching. So on tick, it's going to execute this. The condition is whether it should be counting down or not. So if it's not set to count down, if the clock is stopped, then it won't update the current seconds. Otherwise, it will. It won't do anything. If it's stopped, it won't do anything. If it is set to count down, then it'll update the current seconds. So that's the controller for counting down. And finally, finally all of this math for setting the time. So we have these starting values for minutes, seconds, and hours. This constant, which is converting these all into seconds. And all this is doing is, I already did this. This is set time. Spin time wheels is where we want to go. Yes, this one's crazy. This is a for each loop. So we're going to get the body group wheels, which would be all of those internal ones. And sorry, that's not actually not being used anymore. Find prims is going to get all the wheels. It's going to go from here. And then it's going to find recursively every node and every prim under that. I thought that maybe it was only doing meshes, but I might be wrong. And so then for each prim that it finds recursively here, it's going to go through and feed that over to here. And it's going to then find these attributes, read prim attribute on those prims, number of seconds and angle per turn. So if we look at these wheel groups have extra attributes that they've added. Angle per turn, so 36 degrees on every turn, and then how many seconds that represents. So this is an hour wheel, so 3,600 seconds. If we look at seconds, number of seconds is 10. So and then how many degrees for that turn. So for every prim in there, I could have sworn, I feel like I'm missing something here. But I believe this is checking. This is basically only going to I'll have to come back to this. Start seconds minus the current seconds gives you the current value that it should show here. And then it's doing a ceiling to round up because this can be a float, right? And stop the clock, reset, that should be fine. So it's going to be a float, so we want to round up to that number, convert that back to a double, divide the number of seconds by the current by the current time, and then again and this one you floor, convert back to a double, and then you multiply by the angle per turn. So that'll give you the rotation that you want, and then you can write that out to the XYZ rotation for that prim on that loop. I don't know if there's a better way to debug this for loop, like to see step by step what it's doing. That would be cool, but I'm not sure if we have that control. But for the most part, that's the gist of it. I could have sworn I was looking at this yesterday and it was only doing meshes, but that wouldn't make sense because it's really these that have the attributes. So I think what's limiting it is whether it has these attributes or not. If it doesn't have these attributes, it's not going to act on it, or it's not going to be able to write anything out. Because these don't have attributes. And the parent doesn't have them. So, that's that one. So yeah, so interesting thing there is that the asset itself has these attributes to help inform the graph about how it should manipulate each one. So instead of the graph trying to keep track of what's going on, the logic, the brains of each of these wheels, the wheel, each wheel is informing the graph itself how it should behave. And based off of those two variables, the amount to turn and what that wheel represents, then you have the solution. So let me take one more look at that just to be sure here. Okay, so this first wheel counts in seconds, so each turn represents 1 second, whereas this minute, whereas this one represents 10 seconds. So based off of each of these, and it loops these in order. First, it removes the hours at a time, and then minutes at a time, and then seconds at a time to get to that state. So very cool. That's the clock. Any questions? Should leave us with just enough time for the labyrinth, the maze. It's called a labyrinth maze. All right. Oh, I guess it is both. And you guys should definitely play with all of these. I think they're really fun to interact with. It can't do it justice. It is a pretty cool experience to it's almost a tactile experience to move these with the mouse. So this one, I'll open the graph later, but this one we press play, and it's gonna use the drag state to figure out to tilt each of these up or down or left and right. And I'm not gonna win this, I don't think, but I will try this one time. I made it, and it's counting down. When I reach the goal, it stops the countdown to let you know how long it took you to get there. That's my record so far. Last time it was like 2 minutes. And then there's a level toggle, so I'm not even going to try this one. Yeah, I'm not going to make it. So, and here's the kind of the recommended path to get there, but it doesn't matter how you get there as long as you get there. Cool. So let's take a look at this graph. This one has lots of graphs. And it uses a different approach. So if you've stuck with me to this point, This one's actually fairly different, and there's more concepts to learn here. So this one's using multiple graphs instead of just one that's kind of was using variables to communicate between the different graph sections. This one is using custom events. So we have this setup that we've seen before. It'll take me a little bit of time to remember since these are different by design. It'll take me some time to remember what these do, but this is the same idea. We have the start, play, stop for the scripted versus default viewport modes. And when you stop, it's going to reset the maze positions, the maze rotation. So that one's easy. We have the drag state again, and this is controlling the tilt on the maze. This one's actually more subtle. It's grabbing the mouse position to determine if the drag is currently in progress, and if it is, then on tick we should check to see if you're dragging, and if you are, then we need to rotate these walls. So this is the inner wall is this one, and then the outer wall, no, maze, inner wall, maze, inner wall, maze. So inner wall is that one, is this second, the middle one, and then maze is the very innermost. So when I drag, the innermost only goes left and right, and the middle one goes up and down. And then you can combine those to get a final rotation. So yeah, that's controlling whether if dragging is in progress, that's going to control whether to write out the position or not. And then for this, it's going to calculate how much the drag has changed, and from the initial position of the drag, and then adjust the rotations for those accordingly. So that's the whole controller for the maze. Not too bad. And then here I can swap mazes, so this is a nice way to work as well. You can quickly swap between graphs. This one is reset game. This one is occurs from a custom event called restart game, and it's going to reset the ball position to the ball start variable, and track ball. This one's actually going to track where the ball is positioned, so it's going to get the steel ball's translation. On tick, it's going to compare here the position to 0, and if the position is at the, what is this doing? Oh, it's checking the Y. So this is actually and what does it compare? If the height of the ball is less than or equal to 0, then it will fire this, and it's going to reset the ball. So, and also fire a reset game. So yeah, so if the ball falls through a hole, then reset the game. That took me a while to get, but yeah, goes into there and it resets. And this is the other part. So this was the on custom event. This is the setting the event. So I can say when this event should fire with the exec in, and I give it the event a name, and then when this node executes, this one will execute because it's receiving that event, and it's repositioning the ball at the start position. So that one's cool. Timer graph, I'm not gonna, I don't think that one's, I'll open it up, but I don't think it's worth looking at. I mean, we looked at the clock and it's a similar idea, right? This one's just counting up, I believe. So this may be a little interesting. It's splitting seconds and minutes. So it's gonna grab the number of seconds, compare it to see if it's bigger than 60, and if it is, then it's going to put minutes and seconds. Otherwise, it's just going to write seconds only. So if I start this up again, actually, I don't know if this resets. So that's the end time. I'm sure this resets somewhere, but I'm just going to reopen this just to see what that looks like when it's only seconds long. So if I start that, I guess it is still minutes and seconds there. But anyways, this is just controlling what to draw on that timer string, that debug text. Timer event gets fired basically on tick, I think, right? So on tick, it's actually going to send this timer event, and only if should be another event here, sorry. No, it just writes out that prim attribute to world data. So there's also a data. This one's using attributes on a prim as data for this graph. End time, stop timer. So lots of flexibility as far as whether you want to use graph variables or put them on a separate prim, or on the asset itself, like we saw with the clock, where the angle per turn and the number of seconds that the clock represents, that the wheel represents, is written on the asset itself. So different options there. All right, let's look at win game condition. So this one is checking, it's getting the position it's the world position of the win game X form, which is the flag. No, I think we have something separate there. Where is this thing? World win game X form. So it is at the flag, but it's a separate X form. So it's getting that world position, and then it's also getting the steel balls position. And on tick, it's checking to see if the distance between those two is less than 12. It is less than 1.2. If it is, then the ball's made it to the end zone, and we can write out the winner variable, and winner variable would be written out to false, I believe, and or to empty string or winner, depending on that condition. And then if it's empty string, I guess this fires every time anyways. We execute the winner event. So when the ball does reach it, it fires a winner event with the value of true, hold on. When the win event or when you reach the end zone, fires that winner event, and also it writes the stop timer attribute to true. So stop the timer. Otherwise, don't stop the timer. So a little bit of sequential execution that threw me off there, but these are basically disconnected. You want to send that event and also write the stop timer. Lastly, I think I'll end with this is the board level. So this is also very cool, is that this is just a button for switching the level. When we toggle the level, it's just a Boolean. There's only 2 levels. And we send an event to that we're picking the level. And this is just this is the position for the ball at the start. So it's gonna this is the position of the end zone for the maze. So as we swap, you can see here that the flag flew away. But you can see that the flag moves between the 2 levels. I'm guessing that's physics simulated. I'll need to check. I didn't look at that, but unrelated to action graph. Reset the level. That's gonna reset it on start and stop. But the other more interesting part is what controls what prims and colliders are used. So when you pick a level, when that event fires, it's going to check what level of the 2 it should show. And this one's the one that is finding prims based off of type mesh. So it's going to recursively check from maze level 3. Where is this maze outer wall? Maze outer wall, maze inner wall, maze, and there's a level 3 and a level 1. Right now level 1 is showing, and so it's gonna, for level 1, it's going to go recursively to find prims from level 1, and it's only going to grab the meshes, and when it finds them, it's going to go through each of those meshes and set the visibility to it's going to set it to visible, or to inherited, which is essentially visible, and it's also going to enable the collisions for that mesh. So right now, level 1, we can see here that collision is enabled for this one, and the visibility is inherited. But if we go to level 2, which we're not currently on, we look at this wall here, and visibility is set to invisible, and physics Did I miss it? Collision enabled is false. So that's all that's doing is for each of these. This if determines which based off of the level, whether it should be inherited or invisible. And that's it really. We just once we've looped through all of those, we write out these attributes that it should be visible and whether collision should be enabled for each of those. And that's it. So not too bad. This one might be easier, I guess. Cool. So that's everything that I wanted to cover. That's a very long overview of all the graphs, but we went through every node used, explained what each of these nodes are how they're being used here, and I hope that was useful. Any questions before we go? All right, so I should also mention, I should have opened with this, is November is coming up next month, and I think Action Graph, it'd be really fun to use Action Graph for that. So November, it's this yearly event for everything procedural. The idea is you create, there's going to be a prompt released on October 31st, and this is from last year. And every day you'll have a different prompt, and you can, the idea is to post a creation of yours that answers that prompt. I didn't quite like last year, but the year before was maybe more interesting. And graphs take there's other sorts of competition or events like this that maybe don't take as long. Graphs can take quite a bit of time, so you could try to do a graph every day, or you could combine multiple prompts and put them and share them all together if you're completionist and you want to try to answer every prompt. Otherwise, at your leisure, try to answer some of these prompts with node graphs at the pace that you can. Everybody has a different time to devote for this, but it's a great time to try new things, try different tools, push yourself to learn something new. And so I just wanted to put that forward that we have Action Graph in Omniverse, and we have more nodes than ever now for doing things. It's really great for behaviors and animation. So I'll be doing it. I'm going to be, I probably won't do every day, but I'll pick out some of the prompts that I think are interesting and try to share some of these. And so the idea is when you share on a given day, you tag it with November, hashtag November 2022. And there's a pretty good community on Twitter around this. Lots of people seeing and wanting to share with one another what they're creating. So highly recommend that you check it out this year. Like I said, the prompt will be announced on October 31st, and you can jump on that for November. So any questions? Okay. Thank you for coming. I hope this was useful, whether you're doing November or not. Check out Action Graph and give it a shot. Let me know if you have any questions on Discord or on the forums, and we'll do our best to help you out. Thanks for coming.